Okay, now quickly coming to the next part of the lab, since we are running out of time. Here we have these symbols as NOT, AND, OR, XOR, XNOT. Now what is the difference between these and previous is it's supposed to compare each parative bit with their respective significance, like fourth parative bit with fourth, third with third, fourth with second, and first with first. Now to demonstrate this, we are going to run this test, and I have already written this in Quartus, already compiled it. You can see here I have 0 errors. Now moving to its waveform, here I have assigned the values that was given in the question: 1100, which is 1100, 0011, and 0101. It's not 1100 because it's binary. And now we will simply compile it. Okay, here we have got our results. Now I will be defining each of the result. So the first result is for NOT of A. It was 1100, so every bit was supposed to be reverted. It was 1100, and now what we have got here is 0011. Hence every bit has been opposed. Now coming to the next part, which is A and C. This is A and C. Now what it's supposed to compare is it's supposed to give 1 only when both the bits of A and C is 1. We can see here its second bit is 1 and its second bit is also 1. Rest of the bits are different, hence only the second bit is 1 and the rest bits are 0. Now coming to the next part, which is A or B. Now OR is supposed to give 1 when any of the inputs is high. Now we can see here the first two inputs are high for A and the last two inputs are high for B. Now matching these two, we can get the high inputs at all of these because we are comparing A and B bitwise. Now coming to the next part, which is B XOR C. It gives 0 1 1 0. Now what XOR does is XOR gives 1 only if either of the inputs is 1. Only single input is 1. Now we can see here for the first and the last, we have both the inputs as zeros and 1. Hence we won't get 1 here. But here we have only one of the inputs from the number in the second and third bit as 1 or 0. Hence we got here 0 1 1 0. Now coming to the next part, which is XNOR of A and C. XNOR of A and C. Now what XNOR is supposed to do, it gives 1 only if both the bits are 1 or both the bits are 0. Now here we have first bit as 1 and first bit as 0, hence they don't match. And the last bit is 0 and the last bit is 1, they don't match. But in the second bit it's 1 and it's also 1. In third bit it's 0 and it's also 0. Hence we can say that the second and third bits were matching. So we got 0 1 1 0. Hence all the results given here are justified from the respective bitwise gates applied. That's all for this part. Now we will move to the next part.